Let's look up. So we'll be looking at the Henderson Hasselbalch equation. And this equation is used to calculate the pH of the buffer solution. It's used to calculate the pH of buffer solution. And this equation relates pH and pKa majorly together, then the concentration of hydrogen ion. So it relates pH, pKa, concentration of hydrogen ion, concentration of the weak acid together. All right. Now, if you want to derive the Henderson Hasselbalch equation, these are the steps. So we are going to follow these steps to derive it. Step 1 says write dissociation equation of weak acid. Now, if you have your weak acid here, Ha, this weak acid, right? If it dissociates, what will you have? Hydrogen ion plus what? And you agree with me that if this thing dissociates, this is the this is what? This proton, right? And this is the conjugate base, right? Good. Now the next step, write equilibrium constant equation expression. Equilibrium constant equation expression. And you agree with me that equilibrium constant given as Ka, right? Acid dissociation constant. Now the acid dissociation constant, or you call it the equilibrium constant expression equation, is given as the concentration of the products all over the concentration of the reactant, right? So the concentration of the product, we have concentration of H plus. Take note I'm using box bracket because we are talking about concentration. This bracket actually. Then A all over the reactant is what? HA. The next step, make H plus concentration of hydrogen ion subject of formula. So if you want to make hydrogen ion here subject of the formula, what do? We cross multiply first, right? So if you cross multiply, you'll be having Ka Ha equal to H plus A minus, right? But what we want is H plus, right? So I divide both sides by what? A minus, right? So I'll be having H plus as equal to Ka all over what? Right? Now the next thing he said, multiply through by what? Minus log. Please, I'll beg you to pay attention here. If you multiply through by minus log, we'll be having minus log H plus, right? Equal to minus log what? Have I changed anything if I do plus minus, minus log HA over A minus? Have I changed anything? Is this correct? Eh? Is it correct? How is it correct? Because times one side and one outside. Laws of log reading. What's the laws of log reading? If it is division, what do? You subtract, right? But we're multiplying 2 by what? Minus log. So yes, it's not supposed to be plus because minus minus. Do we understand this? I'll take that again. This is same thing. We said multiply 2 by minus log, right? So this is same thing as saying minus log everything here, right? Right? Good. But now, this is the same thing as saying minus log. Now, I want to separate this. This stuff here. If I have something like this, You agree with me that this is same thing as saying Ka times Ha, right? Is it not? Now, and we're applying logarithm through a minus log. And this is multiplication, right? Separating them. So laws of logarithm, I'll be having minus log. If I want to separate them, this will be minus log Ka. Since this is times, it will be what? Plus what? Minus log, because we're multiplying through by what? Minus log Ha over A minus, right? So we actually made a mistake here. Minus plus minus will give us what? So we're having minus log Ka minus log Ha over A minus, right? Is it not? Now at this point, we'll have it that minus log hydrogen ion is what? From the definitions, minus log hydrogen ion is what? pH, right? Remember that pH is the negative logarithm of what? Hydrogen ion. So everything here is what? pH. Equal to minus log Ka will give us what? Thank you very much. pKa minus. But now look at this part. If I want to change here to plus, according to rule of logarithm, I will have to take the inverse of this. So I'll be having plus log A minus all over what? Ha. This equation we have here now is called the Henderson Hasselbalch equation. I will repeat this step, then we'll use it. We'll see how we are going to use it in calculation. Now, the first thing is you write the dissociation equation of weak acid. This is a weak acid, it dissociates into this. Then you write the acid dissociation constant, which is concentration of products all over concentration of reactants. Next, you make H the subject of the formula. And that was what we did here. Next thing, you multiply through by what? Minus log, right? So minus log, minus log. Then we said this is same thing as saying minus log Ka minus du of this. We saw how we got that. Minus log hydrogen ion is equal to pH. Minus log Ka is equal to pKa plus, because if you are turning this upside down, the law of logarithm says add plus. So this is the Henderson Hasselbalch equation. In some questions, you can be given pH and you're asked to calculate the pKa. Remember, the concentration of A minus is what? This is what? Concentration of what? Conjugate what? Base, right? Why this is the what? The weak acid. And remember that a buffer solution contains weak acid and its conjugate base, right? So with this, you can calculate the pH or the pKa of a buffer solution. We are going to see some calculations.